Yeah, we can go.
Okay, that's fine. So Lyftron is basically your agile modern data hub for faster analytics, and we can go over what are the major background about Lyftron on the product side. The main idea behind Lyftron on the product is to basically give you a central view of data from multiple data sources to build a modern data hub and streaming on the fly. Our mission is to lower the cost of data management by 75%. That will enable enterprises to query any data with ANSI SQL. Our vision is to bring all data in one place without any major data movement and enable data catalog, data lineage, and as well as data governance on your data. So what companies need from their data is very straightforward. You want to connect with any data. You want to shorten time to insight. You want to query data with SQL, and you want to eliminate your data silos. But achieving it with current technologies is not possible because you have a lot of limitation with connecting with all the sources because your platform does not support that. Your reports still crawl because you have to go through with lengthy process of the source changes and semantic layer changes, and as well as the performance on the reporting side. You cannot query all the data with ANSI SQL because you have to rely on your product to get your data converted from web services, REST, XML, JSON back into relation format. And it's very difficult to eliminate the data silos because your current platform does not support any data lineage, data governance, and the search capability on the data catalog. So these are the four pillars which Lyftron has been formed and helping enterprises to be data driven. So hooray, now you can connect with all of these apps in real time without zero coding, and you can analyze the data instantly with ANSI SQL. And Lyftron is very tightly coupled with Snowflake as well, which is the modern data warehouse. So you can easily able to analyze and load the data into Snowflake pretty much in few clicks. So we'll go over with the sorry, the challenge of a traditional ETL architecture. So this is the classical BI architecture where we are saying that we are reading the data from the sources, then we are loading the data into the stage. We are again reading and again writing into a data warehouse, then again reading and writing into a data mart. So we saw that as at least we have taken at least 4 hops before the data is really presentable into the BI layer and make it available for analysis. So we found this approach is very time consuming. It's required a lot of efforts for development as well as for the maintenance. It's very error prone as well, because if one of the stage fail, then the next stage cannot work. And it's very inconsistent as well because it does not support data replication, the changes from the source, and also the schema propagation from the source. So what exactly schema propagation is? Suppose you build a job with an employee table today with the 5 fields. Tomorrow, if there are new fields comes in, so there is no way the ETL will able to basically incorporate that changes unless you have to go and manually incorporate that change into your ETL. So Lyftron is basically solving this middle piece over here and eliminating the multiple hops that we are taking. So that way we can take only a single hop, and based on that we can build the things logically and use the compute power of the new data warehouse, and the compute power or compute engine of Lyftron Spark comes along with it. That way you can get a better performance and get your data management lifecycle shorter by 75%.
Yeah, just to add to that, Javid, it's very important to note that is one of the key differentiators for Lyftron. It's completely been re-engineered to exclude ETL. So it completely bypasses that process and all the latency that comes with it. It's very unique, and Javid will continue. I just wanted to make that point.
Thank you. So here we are showing you the modern architecture with Lyftron, and here we're giving you example with Lyftron and Snowflake as well. It could be fit with any other modern data warehouse as well, either BigQuery or Redshift, but here for a demo purpose, we are showing Snowflake as the target data warehouse. So we are moving from left to right. So here on the left, you can see there are all the modern data sources. You may be pulling the data from Google Analytics, from Salesforce, Marketer, and so on. As soon as you will connect with Lyftron, it will stream the data and put it into the storage. By default, it supports the storage of Spark, but you can also get the data stored on S3 on Google storage as well as on Azure Blobs. After that, the second engine is showing a data replication. Lyftron has an inbuilt limited data replication capability, which will let you basically replicate the data for the changes based on the field name as well as timestamp field. It will also handle the ELT, which will convert any data that you're reading from the source and convert that into ANSI SQL. And then you can push down that ANSI SQL into your target data warehouse, so you're getting the performance of your data warehouse directly. The other point is it will also basically support a modern data pipeline, which will use to do the data migration from your legacy platform back into the cloud, also for your merging, linking, cleansing, and the transformation side of it. So now once we come into the middle layer, this is where the major magic happens. So as you can see, we are showing you 3 different types of wheels when the data is coming in. So these wheels are logical data warehouse, which we basically spin out in parallel. So we will be using one wheel for data loading, one wheel for data transformation, and one wheel for basically transform data. So with this way, we are going in a very parallel approach and multi-threaded approach to basically pull the data. That's not the case in ETL. And once the data comes in, so you can see that blue layer. So this is our layer where we basically physicalize the data. You can either build a data lake, you can do that physicalization, then we will allow you maybe one more layer of physicalization. And after that, whatever you are building on top of it, either you're building a data mart, data warehouse, or any other layers, that layers could be logical, and that layers will be using the logical compute of Lyftron to do that conversion on the fly. After that, if you want to basically pull the data out of Lyftrons, then we are also spinning out the same gear for logical warehouse, which will be using the Lyftron compute. You will be having a data segmented for data scientists. So data scientists will be viewing the data the way they want. The BI analysts can directly go to Lyftron and they can query the data and pull the data out from any leading BI tools, as well as the SQL analysts can directly go and basically analyze the data the way they want. Any questions over here before we move forward? Okay, so we can get us moving. So this is, we're showing how does it differ from a classical approach. So on the left, as soon as you do the connection, so there is no jobs required to build in Lyftron. If you're coming from an Informatica background, you basically build a job. I think a quick example could be, suppose if you're pulling a data from a CSV file, you have to first import the schema, then you have to go and create the jobs, create the sessions, create the workflows, and then you have to load that process. At least 5-step process before you basically do one single job. In the case of Lyftron, it's a very unique way. As soon as you will connect the sources, it will automatically import all the data sets and create the tables over here in one shot without worrying about creating multiple jobs. After that, you have a logical and physical on-the-fly consolidation where Lyftron will allow you to create the data replication, your data lake, your enterprise data warehouse, stages, data governance, and data mart. And it will use the underlying compute of Spark as well as Snowflake. And then the presentation layer will have direct access to Lyftron to pull the data from your messaging layer that you message the data or standardization layer, as well as from your source layer. So now as a business owner, you can define that what type of data you really want to physicalize into your data warehouse and what type of data you really want to stream. So based on the recent Forrester report, it has been found that only 25% of the data is really required to be physicalized and 75% of the data does not need to be physicalized. But in today's ETL or legacy way, the way we do, we have to basically physicalize all 100% of the data. So this is where we waste a lot of time. And this is where Lyftron is coming and basically helping you solving that big use case here. So this is the approach that Lyftron uses. So in the traditional way, which you're building a data warehouse first, then creating a dashboard. So we found with that is a long delay to first insight, and data governance and data layering has been missing. The second approach that most of the enterprises took was fast and dirty way, where you put the whole load on the data on the BI layer. No ETL there. We found is a lot of issues with the BI performance, and data governance and data layering is still missing. So after years of research, we combine these two approaches and come up with a modern data hub approach, which will make a logical modern data hub and get the best of both worlds, where data is connected in real time and available for use in one format, which is NSI SQL, multi-layered architecture based on delayed sets and delayed caching. So here is a quick example why you need a Lyftron platform for data preparation. On the top, we are showing a snippet of your traditional ETL tool, which is showing you if you are basically going with the ETL development route. So you have to go at least with 4 to 5 stage process. With Lyftron, you are just connecting. It will automatically create your data pipeline, automatically create your jobs. You don't need to create your jobs yourself. And your data is available for analysis instantly with NSI SQL, as well as you can connect with any leading BI tools directly with Lyftron and analyze the data. After that, you can come back to Lyftron and you can do your data cleansing and optimization. So which is where we're saying is 75% optimization, because we eliminate multiple hops that you're supposed to take with traditional ETL tool. So the use cases that you can solve with Lyftron, the very first and unique use case is the cloud migration. Suppose you're migrating from Teradata, from Hadoop, and from your legacy platform. So Lyftron has a very unique feature to do that migration, which we support both lift and shift as well as step-by-step physical migration. So we are showing you both architectures here. So the down one with the blue line is the lift and shift, where the data is not physically moving. You are just moving the logical sets of the data into Lyftron, and Lyftron will create all the metadata. And Lyftron also have a unique feature of creating a universal data model, which will move your semantic layer from your different BI platform into Lyftron, which is showing you at the end over here. So you will take at least 1 month or 2 months to create the data model to make sure that it's fitting based on your new data model requirement. And then you can onboard your business users directly into Lyftron based on the new data model pretty much in 2 to 3 months time, without waiting for physicalizing the data. Now, the second approach we are doing it, we are letting you migrate physically from your legacy instance back into your new modern data warehouse like a Snowflake or BigQuery, which is showing you the green zone on the top. So once this migration has been done, you're doing it step by step or block by block. Then Lyftron is also giving you a capability to compare that migration, that green zone, with this purple zone down there, where you can easily able to compare your new data warehouse with your traditional data warehouse to make sure that everything is kosher based on your data types that you created, based on the schema, the column names, and based on the data that is contained. Normally with the traditional way, you have to do with the complex writing of the queries to do this comparison. I have to basically go with a lengthy process, but Lyftron has inbuilt capability to give you that information. The second use case we are solving is the governed data lakes. What exactly is the governed data lake? We see that enterprises build data lakes, but that can be filled so quickly. You have a lot of data silos. And the major problem is now you have no idea which table contain what information. How would you basically get the data from these tables, because there is no data lineage and data searching available in your current platform. So Lyftron solved that problem very uniquely by allowing enterprises to build either the new data lake on our platform or connect with the existing data lake. As soon as you connect, it will import all the tables from your data lake into Lyftron, and now it will allow you to create tags that you can directly assign onto the table. Suppose you will segment the table based on your PII information, your different departments for HR, sales, and marketing, and also by a specific resource group that you are basically want to segment the data. And based on that, you can easily able to define a definition for those tables. You can define a proper governance on those tables, and we will provide you a full data catalog and searching capability based on the tags and based on the keywords. So that way you are getting a full control of your metadata and have a full control of your data dictionary. So this layer will become your anti-corruption layer, where you're basically covering this as a corporate asset and eliminating any data silos that you have in your databases. After that, we are showing you this green background with 2 cubes on the back, 2 cubes over there. So we have a very unique feature of a 2 rotated tables. So what exactly is that? if you can see, you guys are writing into a star schema, into a fact table and dimension table. So ETL writes to those tables, and then BI basically pull the data from those tables. So we see a lot of performance issue with that, because at the same time, ETL is writing and BI is reading. So a lot of enterprises basically end up creating a separate semantic layer for stage to eliminate that issue. But Lyftron has inbuilt capability to handle that without you worrying about it. So Lyftron create a dedicated table for inserts and also dedicated table for read. So as soon as the new record comes, so it will go into the insert table, and as soon as that load ended, then Lyftron will automatically merge that load into your BI table. So that way you are not compromising to your BI performance, and directly the data is basically coming seamlessly for the BI users. One of the other unique use case, I think this will be very useful for you guys, as well as you guys are using multiple BI tools. So we are showing you an example over here that you have Power BI, Tableau, or ClickView. And then here we have the sources coming through, and in between, this is the Lyftron layer. So the major challenge come over here in a traditional way is if any change comes from the source, so you have to apply that changes manually into your ETL data pipeline, as well as manually into your semantic layer of your BIs. So you have to go into ETL data pipeline and have to go manually into Power BI, Tableau, and ClickView to apply those changes. Not anymore, because Lyftron comes up with a universal data model concept where we are saying that instead of keeping your semantic data model into your BI, you can move that semantic data model into Lyftron, which is showing at the end over here. And that will become your corporate asset. Lyftron let you design the data model, either your star schema or your cubing logic. And then if any change comes from the source, Lyftron pipeline automatically basically absorb that change and push that change into your data model over here. So this way your BI is self-sufficient. You just need to pull only the new columns into the BI into your dashboards, and you don't need to worry about doing that changes into the semantic layer. And other use case that you solve is now you basically remove the dependency on the BI. Suppose tomorrow you want to bring any cheaper BI tool, which is better, or you want to bring a AI-based BI tool, then you can take that decision in no time, because now you don't need to recode that semantic model into the BI. Because that model is sitting in Lyftron, you can directly connect any BI tool to Lyftron and have your report up in no time. Any questions over here? Okay, so we can move forward. So one of our major use cases, data sourcing for SaaS BIs. This is basically very important for the hybrid cloud management. We see that a lot of enterprises took decision that they are keeping some stuff on-premise and some stuff in hybrid cloud. Maybe you have some data in AWS, in Azure, and Google. So now in the traditional way, your BI is directly basically pulling the data from on-premise as well as joining on hybrid cloud. So that way you are getting basically a lot of performance issues, because BI has to go with multiple hops to pull the data. So this is where Lyftron will comes into play, and Lyftron will sit in the same region where your BI is hosted and where your different hybrid cloud is hosted. And Lyftron instance will basically sync the data back into Lyftron and cache the data into the Lyftron cluster. So that way you don't need to worry about any lag of the performance of pulling the data. So in this case, BI will directly interact with Lyftron and pull the data out, and data is instantly available for query in no time. And you will easily able to eliminate the syncing issue that you have between your on-premise data and your cloud data. So this is the end of our presentation, and I can go over with the demo. If you guys have any quick question before we can go on the demos, I can answer that now, and then we can quickly jump into the demo. Arif, Hannah, any questions here?
What kind of customers have you implemented this in the past?
We have implemented this in a retail domain in Europe as well, and we have customers in in the financial domains, in the media as well, and in the basically e-commerce domain. So it's a very diverse set of customers. So majority, I mean, we're seeing a lot of demand from different sectors as well. And recently we've been basically implementing in the insurance domain as well.
And how does it work with the big amount of data sets? I mean, if the data is growing fast and you are maintaining all the history, how does the performance, how is the performance in those cases?
It's handled in a really unique way, because Lyftron comes up with the inbuilt compute power of a Spark. So you have a Spark power along with it. Based on that, it will cache the data, because you will schedule the job based on the changes that will pick up the delta. So you are not going and querying from the source all the time to pull the history. So Lyftron job will take care of that, and you are directly pulling it from the Lyftron cluster.
So is it so that if the same job is run by two different users, then the Lyftron will compute it twice?
No, Lyftron will compute it once.
Okay.
And then you will be directly reading it from the Lyftron cluster. So once you do this caching, so this is basically caching is based on, suppose you are having very high running queries that you have on your platforms, that you see that a lot of people are using it more often. So you will cache that query data into Lyftron, and now every time, and then you will basically schedule the changes on that query that Lyftron is keep on running in the background and capturing the delta on those on that query onto Lyftron cluster. So every time you're directly pulling the data from Lyftron, and Lyftron is basically giving you the data instantly. It doesn't matter how many users can query the data.
Okay.
Because we allow multi-threading and also the concurrent queries that can run in parallel.
All right. Thank you.
So let me quickly go on to the demo here. So this is a Lyftron instance. So it's a totally web-based UI. There is no need for any physical installation. You can directly access this from your browsers. And it's a PaaS product, which you can basically pull out. Either you can install it on-premise, or you can have it available from a marketplace, which can sit directly in your private hosting, and you will control your Active Directories and so on. So as you can come in, it will give you the very nice looking view of a dashboard, which will show you how many databases you have been basically linked with Lyftron, how many connections you have open, how many tables you bring it into Lyftron, number of users that are working, total number of active connections, and total number of jobs that have been running. We have an inbuilt job scheduler as well, so you don't need to worry about scheduling separately. And this is the admin view. So admin can see all the type of data, all type of queries that has been running. And then you have a separate views for different users as well. And from here, it's showing you what type of data has been pulled, what type of products have been pulling the data out of Lyftron as well. So we have a very robust administration panel where we are mimicking exactly the same rights as you can see at the database level. And you can create the users and roles that way and assign the access to them exactly the same way as you basically see it in your database. You will have your full user management here. You can directly connect with your Active Directory, so that way you can manage your users directly from Active Directories, and that will be synced up into Lyftron. Role management, you will define your job, and Lyftron is the only platform which will let you run any external scripts job if you have on Python, and so on. So you can directly call that in Lyftron, that will directly apply that output into your data pipeline. You have a specific scheduler as well. You can define your own scheduler. It's dynamic to basically adapt based on your changes and apply the scheduling, the logic based on what you decide. Very unique feature of a SQL dialect here. Suppose if you're moving away from Teradata into a target. So we have built a type conversion logic over here where you do not need to worry about doing a typecasting into your target data warehouse layout. Lyftron will handle it automatically. It will automatically convert any source data back into NSI SQL and then push it down into your target data warehouse the mapping requirement, where you do not need to worry about that what type of data type that will be using, how would you convert that. We handle that automatically. Apart from that, we will provide a full query feature from our side because it emulates SQL Server protocol on the fly. So you have a full database feature as well with Lyftron, where you can run any query from our platform in nSize SQL on Teradata as well. These many SQL features are supported. Similarly, these many functions, we support more than 2000 nSize SQL functions that you can run from our platform directly to any sources. For instance, you are getting the data from any NoSQL platform like a Mongo or Elastic. So those are the NoSQL, but from our platform, you can directly run select queries or nSize SQL queries onto NoSQL platform. So you don't need to learn any dialect per se from your source systems, because from us, you can query directly with SQL and we will convert that logic into the source system. So that way, it makes life pretty easier for the customer or for the business users or analysts. Then they can query any data into SQL without worrying about coding based on the SQL dialect requirement or source direct requirement. So we have engine configuration here, which will handle your metadata over here, different nodes of Lyftron, and then this is a Spark instance that comes along with it, with Lyftron cluster. You can either use our Spark instance and you can connect with your own Spark instance if you want to do a much more, you want to scale and get a better performance, then you can scale that. You can connect with any cloud-based Spark instance like Databricks and so on through us as well. Now, this is a business terms which we talk about a segmentation of a data specifically by the business groups, specifically by your PII, your personal information, and specifically by your resource group as well. So here we have segment the data by finance and specifically by HR group, by PII, and specifically by the QA department and so on. So we will allow you to basically create the tags, and these tags can be, here you can set up the relationship of these tags, and these tags can be nested. We will allow you up to 5 levels of nesting in the tags as well. And this is where you will go and search, assign these tags at the column level, at the table level, at the view level, or at the database level. Based on that, that will be available, those sets, tables, or those objects will be available directly in the data catalog for you. So here we define all the connections here. Suppose you go and do the connections. Suppose we want to do it from Teradata, then we have a Teradata connector here, which you can directly connect. Based on the Lyftron node, if you're choosing any node, it will choose it automatically. If you're using manually, then it will run on that node. Then you can define your settings. It will basically connect directly with the Teradata. And after you're done with the connection, similar way, you can connect with any third-party apps as well, like Bing. You can connect by simply passing an API key. Similar way, you can connect with Facebook, simple initial OAuth, and passing your tokens, private key and public key. You can connect with Gmail, with Google Analytics, Salesforce, so on. So we support 140 connections, so there are a lot of sources as well. And there is a very unique way that how we handle the connectivity with CSV as well. So normally with Informatica, you have to basically import the schema of the CSV files manually into the table, into your Informatica, and then put it into your jobs and so on. If you are having 100 CSV files, then you have to basically have that import done manually. In our case, it's a very unique feature. In our case, we will directly map to the directory where your data will be coming, and our platform will automatically import the schema for you. And you can also, it will also handle the subdirectories of that as well. So for instance, here I am linking this directly on my platform, which is having the file sitting over here. And I don't need to import any file. I just did the connection based on this. After that, I will just simply, suppose if I need to have a new file, I will simply create my new test over here. That's it. And I will go to my database here. I already have my CSV. So either I can do this import metadata manually, or we can schedule that as well. So that will do that import automatically for you in the fly. Simply go here. I have this file already available. It's automatically converted my schema. I don't need to do that conversion myself. If you click all, it will automatically import all. In this case, I already have others, so I will just importing these ones. So you can see this file came, and now you can directly preview the data here. You can see all the columns. So this will become your external table. So we basically solve that external table concept very uniquely. You can define the primary key, you can define the foreign key, you can define the specific access right as well, to which user we can basically give you an option to define that rights at the column level as well. And you can also define that business term. Suppose you want to have this specific table file came in, and you want to define the tagging based on the data that this contains some personal information. Suppose this is having, let me see if it's having any name or something. It does not. So let's say we consider this as your information. So you can directly go into the business terms, and you can go into the sign here and choose all the tags that you created here. Suppose I consider this as my personal information. I will assign this tag. And I also consider this as the group for HR. Then I will assign this as the tag. So this is at the column level. And then we can go at the table level as well. You can define the same thing at the table level as well, where you can go directly in the business terms here, go to the sign, and then you can say this whole table is from HR. Now I can directly go into my search criteria. So this is where we basically give you a full insight of your data catalog. So whatever tables are there or whatever objects are there, you can directly search. I can simply search by specific keywords. It's telling me with the employee name, there are 18 tables, 6 views, and 5 columns. I can filter it down only on the tables. It will give me the definition of those tables. So you can collaborate that in real time, put up the comments, whatever you would like to talk with the different group of people that you're collaborating. You can include your children's, include the parent for this, then it will basically increase the number of count. You can go back, and now you want to search it by which of your tables basically include the PII information. So we just linked this thing with your, we just saw this thing with linking with the current table as well. So that will also basically come over here. This is a file that we just recently linked with Kesco CSV, and we have linked the product ID, so it came here. So you can see this specific field is PII information. And you can also have a columns only and the filter by basically based on the views as well. So here we have that specific view that we just created here. You can filter it down with multiple tags as well based on your requirement, and it will basically filter the data out. Suppose you want to take the stuff from HR, it's giving you, we have linked directly this table at that level. So it's giving you that table information as well, which is this table information. So you can filter it down and pretty much up and down. After that, we have a full-fledged query feature as well, where you can go and you can query your sources directly from our platform. You simple drag and drop here. Suppose this is your CSV source. I can simply drag and drop. You can query any type of data. You can include where clause, merging, whatever you can think of querying from a normal SQL client, you can query from our platform. And it will give you the full capability of NSI SQL to do that query as well. Similar way, we are connecting with Elasticsearch as well. So once you connect with any NoSQL, we convert that into relational format automatically here. So you can see you can query Elastic as well on the fly. We can query Salesforce here directly. So all these sets are available directly on the fly. So now you basically bring the data in. Now, how would you basically create a specific joins and basically the merging and so on? Suppose I need to create a data pipeline now. So I simply go here. I'll go and create a join over here. I'll say this is maybe Casco star. I want to create a star schema here. So we allow you to create the cubing as well. So we'll give that example. I'll show you a little bit later. So let's go on to the join here. Go next. So you can easily able to segment the data the way you want. So I want to do the join on my CSV files. I want to join with my data lake over here with my existing star schema. So I pull that star schema as well. I can pull my existing unions as well if I do have. So I can drag and drop here. I can pull some data from Facebook as well. Pull some data maybe from Salesforce as well. So wherever you're dragging and dropping, it will figure out the path of your joiner. You will click here, it will ask you what type of join you want to do. And if it's having a matching field, it will take that automatically. In this case, there are none, so we have to choose. And the type of joins, I'll make this to the left. To the right auto join. Full join here. And similarly here, I'll do an inner join. So maybe something we are joining on a different field, I believe. Let me see which one was that. Yep, this is the ID here. And from here, you can choose what type of field you want to pick and also change the field names here. So we are right now picking all the fields from the source. Maybe from the star schema, I don't want to pick all the fields. So I will choose maybe few of the fields here. And from here also, I don't want to pick all the fields. I'll pick up only very few fields there. So it's automatically basically converted into the full SQL for you. And then you can go back, it created the whole schema for you. We go and create. So this is the star schema we created. Is a very unique thing that we are doing over here is a data lineage. So normally in your traditional ETL tool, you miss this information. Suppose you are having a data coming from a stage, then you are basically using the data into multiple stars and multiple stages, and then the data goes into your semantic layer. But none of the tools provide you a data lineage. But in our case, we will provide you a full detailed data lineage. Suppose this is a star that we created. It shows me the full path of the star, that where exactly the star data is being coming from. So we'll link another fact table to it, another star schema to it. Is giving you the full path of that star schema, that where exactly that star schema is basically pulling the data from. So you can get from top to bottom, the full data lineage. Suppose if I need to figure out where exactly this field came from, so it will give me the full path of that where exactly it came from. Maybe it's coming from a right, somewhere it's coming from here. And I can go from bottom to top as well, directly here. So it's a very unique feature. You can directly go and you can directly check the stuff and give you the full modeling or full traceability of your data processing, that how the data has been moving from one stage to another stage. You can check the similar thing into your dependent as well. If you're using this specific star into other tables, or into other lineage, then that will be shown over here. You can define a primary key and foreign key, define the access right here. We provide minimal data profiling as well, which will give you a distinct counts as well as average length as well on the fly. And this is very important. So this is where you will basically define what type of caching you want to do. Is the two-roted table is the same concept that we discussed about, that it will create one table for insert and one table for your basically read. One table, this is where you define whether you want to do a full load or you want to do an incremental load. Suppose if it's an incremental load, then it will ask you from the source which field you want to apply the changes on. In this case, I say, okay, I want to pick it based on the product ID. I'll save this. You can go into the management task, go into the rebuild cache here. Either you can run it once or you can define the scheduler for this. And you can add a scheduler. So now based on this scheduling, it will go back and it will keep on looking for the changes from the source and keep on loading the changes into the Lyftron cluster for you. So that way you don't need to worry about loading the data and basically worrying about reading the full load every time for you. Any questions there? Similar way, I can show you a quick example. Suppose you are loading the data from Google Analytics. We don't have the connection for that, but I can show you quickly how it works for Facebook. Similar way it will work for Google Analytics as well. So once we connect, so you see we did not do any transformation. We just did the connection. I am using my existing connection. I'll go next, and this is where the magic happens. So in a traditional ETL tool, if you have to connect with the Google Analytics, then you have to go with the REST protocol, convert API JSON or XML back into relational format, and then load that data into a database with Informatica. With our case, there is no need for that. We eliminate all that 5-stage process in single-stage process because we are directly providing you the full data catalog of Google Analytics as the tables. Everything has been converted into a relational format for you. And you can directly import all of those tables in just single click, and you can query. Once it's been imported, you can directly query. You can basically do joins, whatever you would like to do on those tables, you can directly do from our platform, because we consider any source as a database for us. That will become as an NSI SQL platform for you. You can directly query them, and we convert the JSON and XML parsing back into relational when we are basically reading from the source. So when you can see the data comes, it will look like a table for you. You can directly preview the data, see the columns, and basically define any primary key and foreign key on the source database as well. If the source as well, even those does not support those, but you can, from us, you can consider that as a proper database. Any questions here? So this is, we are showing you a target connection for Snowflake here. Suppose you want to push the data into Snowflake from your sources, so we can directly go. So you can choose which source you want to replicate the data. Suppose in your case, you want to move the data from Teradata. So we will have the similar connection here for Teradata. And in one click, suppose this is, I'm showing you a source DB here. You will go next. In one click, it will show, it will pick up all the metadata of your Teradata instance. Now you can choose what type of schemas you want to pull from that instance. It's showing you all the schemas here. in one click, you can import all of that metadata back into your Snowflake or Target data warehouse without you worrying about writing any manual jobs yourself. Our platform will take care of that on the fly for you. And once you do that, import, then it will show you that the schema is showing, it will automatically create the schema on our metadata that show that where exactly you have bring that data from. So you don't need to worry about that where exactly the data source came from. We will automatically tell you if it came from Salesforce, we will tell you where exactly it came from. So you are having a proper data traceability and data lineage up to the sources as well. So we segment the data for you automatically. So that way in your new data lake or new data warehouse that you're creating, you have a proper information where exactly this data tables are coming from. So Lyftron organizes that also for you in a very unique way. After that, you want to pull the data out of Lyftron, you can directly go to any leading BI tool. In this case, we are showing you Power BI here. Create a direct connection to Lyftron. And you can see here, whatever database connections that you created in Lyftron is directly being showing onto your BI platform. So here now you can choose directly what type of cubing, the model we talk about, you can create that star schema directly in there. So you can directly bring this into your BI tool. It's not running, so we can pick up something simple. You can directly bring this data into here, load it. With the direct query here, you can import a direct query, and it will basically bring the data into your instance. So now as a business owner, you can define that what type of data you really want to load and what type of data you really want to stream. So based on that, you can really save huge amount of time with your overall data management or data pipeline processing. So this data is available here for the CSV file, and you can choose what you want to, what type of fields you want to basically integrate with this. Arif and Hannah, any questions here?
Yeah, I have one question actually. So couple of screenshots before this one, I think you were showing that we can import our Teradata data model, right, into Snowflake. So the whole thing works as we have a data source, then we have a integration pipeline, which is loading into that data model, and then we have the presentation layer, and yeah. So I understood that you can import the data model, but how do we, let's say our integration is using Informatica. So how does that work if we were supposed to replace Teradata with Snowflake on day 0, let's say? So what happens to the integration jobs, those Informatica workflows and sessions?
Okay, so we basically, you want to, so we will basically provide you to utilize, to even replace your Informatica as well with this. There is no need for Informatica once you use Lyftron. It will take care of your data pipeline as well, because you can directly go. Suppose I showed you that example here. You can directly go and create your overall logic of data pipeline when you're moving the data here. Suppose here it will having a star. So whatever SQL is generating, you can create your transformations directly here. And this SQL is nothing, it's your ETL pipeline. So the major advantage of that is because we push down this thing on a Snowflake, so you are not going with the ETL engine. You are directly using our platform, which will give you the performance of the full ELT, and it will convert any code that you're building with the UI into SQL. And that SQL will be pushed down into Snowflake. And it will be using the compute of a Snowflake logical warehouse based on the type of you created. And it will directly bulk load the data into the Snowflake UI.
Okay, so we take an Informatica workflow or session and we generate a SQL out of it?
You do not. I'm saying you don't need Informatica at all. Once you bring Lyftron, Lyftron will replace Informatica.
Yeah, but we have done a lot of development in Informatica. There is a lot of transformation rules, right? There is an extract happening, there is transformation happening, there is a load happening. So who will do that?
So from Informatica, if you already having, suppose you're having a select, did you do that in your select query in a SQL override, or you did that into Informatica basically components?
Both. So in some workflows we override SQL, and in other cases we simply drag and drop and join and all of that.
Okay. If it's a SQL override, then eventually, because it supports ANSI SQL, so that way we can directly copy that query and put it over here, and that will create your data pipeline pretty much on the fly for you. For the other ones that you have, that you're using maybe filter and you're using other processes, for that, we have to do that conversion.
Yeah, so that was exactly my question. So point being that those SQL override workflows, we take the SQL and put them in the Lyftron, and it should work fine. Yes. And those other, where we are using drag and drops and filters and all of those, we have to redevelop them. Is that?
Yes, there are, as I will mention also another like architecture that you can take with Lyftron. You can actually connect Lyftron both to Teradata and Snowflake, because Lyftron will work as a kind of SQL proxy layer that looks like SQL Server. So this way, you can, if you mention that you have so many workloads and so many transformations defined on Informatica, you are just a perfect customer that cannot do a lift and shift modernization just one day, and you switch the database on the target database for data loads on Informatica, and everything works. It's just not possible. So you can connect both Teradata and Snowflake to Lyftron, consider them mostly as data sources. So their primary use will be as a data source. And now you just connect BI tools through Lyftron. So whenever you move an area from Teradata to Snowflake, it will not affect any data models in BI tools. You will be able to take SQLs that you use for transformation. The Teradata SQL is quite close to Transact SQL that we use for transformation, so it will be a pretty copy and paste translation. And you can run that. The third option is that if you connect both Teradata through Lyftron and Snowflake, you could connect Informatica directly to Lyftron and do data loading to Lyftron, and Lyftron will just forward all those data loading operations to Snowflake. So you would be able to switch the platform where we are sending the data. Lyftron data loader for Snowflake is the only loader that is using a streaming load. So it does not create like Fivetran. It's not creating temporary files on the Fivetran server to call Snowflake CLI command line tools to load a text file to Snowflake. We just, when we receive the data from sources, we stream them directly to Snowflake, and this is what we work directly with the Snowflake connector team, the team that is responsible for database connectors.
Okay, so this option where you explained that Informatica would be connected to Lyftron, and Lyftron would be loading data to the target, and target could be Snowflake instead of Teradata, right?
Yes.
So in this option, our existing Informatica development will work, or do we have to still redevelop something?
Well, if you have some heavy development, mostly it should work. Maybe it will you will just need change the connection from connector from SQL from Snowflake to from Teradata driver to SQL Server driver. So
so Lyftron, underneath Lyftron is a SQL server.
Well, it's not SQL Server, it's just behaves. So the SQL Server protocol actually is fully documented and it's royalty free. Microsoft had to release this protocol due to some dispute with the European Union. So this protocol is released from any patents or royalties. We just are able to implement it and simulate it and use it as a wire protocol to accept any BI tool or ETL tool like Informatica to connect through Lyftron and translate those codes somewhere else. So what we will do, if you connect both Teradata and Snowflake, you can initially keep your Informatica infrastructures, and then when you will be translating the data load and moving some database areas, like areas responsible, like single data marts, when you move them to Snowflake, you will just change the definition of views in Lyftron, and now those views will read data from Snowflake instead of Teradata. So data model for BI tools will be affected.
So it's basically, if I understand it correctly, it means that we can, first we should put Lyftron between Teradata and BI, and then we start building Snowflake slowly by rewriting the Informatica workflows, and one by one we start only those portions which are redeveloped in Snowflake. We change the Lyftron pointers to Snowflake for them.
Yes.
Right?
One option, yes, exactly. Another option that you may consider is if you would look at some like best practices for modeling data warehouses from Gartner. They say that it's good to have some one tool for like data sourcing, where you load the data into staging tables or like data vault tables. I don't know if you have a data vault model. This is something that is managed purely by like the very backend IT team, data warehousing team. And then you hand over the data modeling about like data marts or views over data marts to do like a segmentation of data marts, like virtual data marts that is a subset of data mart with a joint to yet another table, yet another dimension. And you just hand it over to BI teams. So they use Lyftron to build data marts or some views over data marts virtually. This is one of the recommended patterns for logical data warehousing. Because those people anyway, the BI teams will connect to your data marts or to your tables in the data warehouse from whatever they use, Tableau, Power BI. And if they just don't have the data that they need, they will just connect directly to your staging tables and join across, like, for example, a fact table that is already at the upper level of the data warehouse with a staging table that is not even cleansed. And you will have no control over that until you look at the database logs on Teradata and notice that somebody is joining your staging table. So this way is so Lyftron may be used as a semantic data model for BI teams to give a kind of, to bring some higher level of data governance for BI teams and avoid the issue that they hide all the data transformational joins, data preparation inside the models of dashboards. Because now they share it and you have some visibility over that. If they do some transformation after connecting to your data mart, they actually create a kind of a virtual data mart with extra filters inside a dashboard.
Yeah,
but
makes sense.
You define it, once you say, since now you will be defining that in Lyftron, because Lyftron has both the connection to Teradata and Snowflake, and you don't need to worry where the data sits, because when we move the data from Teradata to Snowflake, we'll just switch the view, but you are not affected.
Yeah.
Yep. So I think you can define eventually, if you want to carry on, you can move some load from Informatica that can be moved instantly to Lyftron, and for other load you can define a specific path. Maybe you can do it slowly, transitioning to it. Or
yeah.
if you like, you can continue using both tools.
Yeah, I think the reason I asked this question originally, I would like to give some background, was that we are bound by some time limitations. So it's not really easy, or let's say it's not really convenient to say that we don't have enough time to rebuild everything. So we are trying to evaluate the options that if we decide to change the technology from Teradata to Snowflake, do we really need to redevelop? And if we really need to redevelop things, how much we have to redevelop and how much will work as is? And the reason is that we don't really have enough time to redevelop. This warehouse has been, so think of it in a way that we have around 1,200 Informatica workflows. So it's not really enough time to redevelop. And most of them are not SQL override. So it's not really, there is not enough time to redevelop. And that is what we were trying. That was the reason I asked the question originally.
Yeah, I think in that case, as Peter mentioned, so we will, you can point that to Lyftron, and Lyftron will take care of that, whatever you're doing in Teradata.
So that's why we are targeting this, let's say, we give this opportunity to do a phased approach to data migration between data warehouses.
Yeah, so it was a good explanation that we can phase out the whole transition.
Yes, to do a phase out in a safe way, and use Lyftron as a stable semantic data model to all data tables that you have in either place, whenever you move it, as a stable data model for BI tools. Given the fact that Lyftron simulates SQL Server on the wire, you can connect from any BI tool, even from Excel, to see the data. So it's, actually not every BI tool is yet supported by Snowflake, but every BI tool has SQL Server drivers bundled, no installation needed. So that's a huge difference. That's why we simulate SQL Server protocol because of the highest possible actually compatibility with any BI tool. This is the only type of driver that is bundled with every BI tool that you can imagine. Even Microsoft drivers are now open source.
Yeah.
Yep, and I think that will give you a much more flexibility on the BI side as well, because you don't need to do any change, and you can directly point your BI as well to Lyftron, and that way it will basically sync up exactly the same points.
Peter, what would you expect in terms of turnaround? You would probably need more information about their data sets, but it seems like their concern is time and being able to make a transition in a timely fashion without having to redevelop certain aspects of what they've done. So it would sound like we probably need more information about that data, but under normal circumstances, what kind of time frame do you think we'd be looking at in terms of transition?
It's well, having about 1,200 workflows, I think at best you will probably spend maybe even a year on moving that. It's hard. I don't know how complex are those pipelines and how many people do you have who actually know those flows and are able to do that. But for sure, you need a solution to do a phased migration.
Thank you, Peter.
Yeah, but this anyway, I think the time, let's say our current Teradata platform has end of life in August 2020, right?
Okay, so it's 1 year anyway.
Yeah, and we need to, either way, we need to decide the technology at some point in time, and then based on that, we need to have a plan how we are going to migrate. But currently, I can say that end of life is August 2020. So.
Okay. Maybe if we just know a couple of information, how many tables do you have? I might expect it's more or less 1,200 based on the Informatica workflows.
No. We have, I think we have around 400 tables.
Okay. And
400 atomic tables.
Okay.
And the methodology that we use is ETL. Okay. So we get the data in a landing, then the landing is basically a file storage. And from there, we load the data to staging. Now staging is inside Teradata, and from staging, we apply transformation, and it goes to load ready. And from load ready, we apply the data to atomic level. And then we have a semantic view on top of atomic level. And business is using the data using semantic views.
Okay.
And semantic views are a mix of both one-to-one atomic or some kind of denormalization or aggregation or something like that.
Yep.
So semantic views is mix of both.
Yep. So you can directly hook up your landing zone with Lyftron, and it will create the same stage as you're creating on Teradata, on Snowflake, so that your Informatica mapping, wherever you're starting from, I believe you're starting from landing to staging, only that job will be replaced. And from stage to moving forward, all the downstream job will remain same.
Yeah, probably. I would guess so. Yeah.
I have a question for Team Kesco. This is Ashby at Lyftron. And the question is, do you guys see the inherent value in Lyftron, the differences in how it operates as compared to an ETL tool? Is there an appreciation for that? I'm just trying to make sure that we've gotten the message across.
Well, I can speak for myself. Hannah can also give some opinion. I think this is a very good demonstration. There was a lot of good things that we can use here.
Very good.
And like I explained, I think this is very interesting. We are evaluating different technologies at the moment, and Snowflake is one of them. And the main idea is that we would like to avoid re-engineering too much. And it seems like Lyftron can do a lot of it, if not everything, but a lot of it. Maybe it does everything, but I would say that 1 hour demonstration and discussion is not enough to make that conclusion that, hey, but I would say it's interesting.
Very good.
Yep, and I think we are not target data warehouse driven. If you decided to move other direction away from Snowflake as well, suppose you decided BigQuery, so we can do the same thing with that as well.
Yeah, but we are evaluating Snowflake, so why not say it?
And Lyftron works very well with Snowflake.
I'm sorry?
I said Lyftron works very well with Snowflake.
Yeah, that is good.
Power of Snowflake.
Are you evaluating any other databases in the cloud except for Snowflake?
Yeah, so Teradata is one of them, and Snowflake is another, and probably